All right, let's look at the probability density function. All right, so here's the definition. The probability density function is a real valued function defined on some interval, so I'll just say interval from A to B, such that there are only two conditions it has to satisfy. All right, so since it's a probability, we don't want to talk about negative values. So the density has to be non-negative. So that's the first condition. All right, the second condition is that since the probability, 100% or, always happen, probability is between 0 and 1, so largest probability is 1. So if you integrate the probability density function over the entire interval from A to B, then it has to be exactly equal to 1. So if you look at the picture and it has to be non-negative, which means that the graph has to be above x-axis, right? Or it could hit the x-axis. And then the area under the curve from the entire over the entire interval from A to B has to be equal to 1. So the area here has to be always equal to 1, right? So those are the only two conditions the probability density function has to satisfy, right? So let's look at this following example. All right, so you have a function f of x equals k times square root of x times quantity 1 minus x, and over the interval from 0 to 1. Right, so what would be the specific k value so that f is a probability density function, right? So let's check both conditions. First, okay, so since x is between 0 and 1, square root of x is positive, and 1 minus x is positive, non-negative, I should say. So as long as k is non-negative, first condition is easily satisfied. How about the second condition? So this is a major one. So let's look at the second condition first here. All right, then you have so we need to make sure that the integral from 0 to 1, and the function is k times square root of x times quantity 1 minus x, right? And this has to be equal to 1. So this is the condition, the second condition we need to satisfy, right? Probably we can get a clue for the value of k from this equation. All right, so let's do that. All right, so first thing is since k is just a number, I'm going to kick it out. So this is going to give us a k here outside, and we have an integral from 0 to 1, right? And then I'm going to go ahead and distribute this guy. So to 1, so it's a square root of x, so I'm going to write it as x to the 1/2 power, right? And then I'm going to distribute square root of x to negative x, so that's going to be negative x to the 3/2, right? And with respect to x. All right, so let's compute that, and at the end, we're going to set that equal to 0. All right, so this is going to be equal to, so maybe I'm going to go down here, maybe go here. All right, so k times, antiderivative of x to the 1/2 power would be x to the, add 1 to the power, so it's a 3/2. Divide by 3/2 is the same thing as multiply by 2/3. All right, and the x to the antiderivative of x to the 3/2 is x to the 5/2, add 1 to the power. Divide by 5/2 is equivalent to multiply by 2/5. All right, then luckily we're going from nice number 0 to 1. All right, so this is going to be equal to k. All right, and if you plug in 1, you get 2/3. Minus plugging 1, you get 2/5. And since minus, if you plug in 0, everything is 0, so I'm not going to even write that. All right, so I guess I would have to take the common denominator, so it's going to be 15. All right, so multiply 2 by 5, so it's 10, minus multiply 2 by 3, so it's a 6. So it came out to be 4/15. k, right? But we know that from the second condition, this has to be equal to 1, right? So this tells us that by multiplying by 15/4, we can isolate k. So you have a 15/4 is the value of the k, right? So if k is equal to 15/4, the given function f of x is considered to be a probability density function, right? That's it. I hope that this was clear.